So restart. This is a very interesting problem. It's a very hard problem. Uh, let's see what it states. It states that we are given a position and a speed. Our initial position is 0. Our speed initial is +1. There are two instructions, A and R. If we process instruction A, we are basically increasing our position to the by whatever speed value we have currently, and we are incrementing speed by a factor of 2. Similarly, if we process R, in that case, we are basically changing speed, if it's positive, to -1. Mind here, we are changing from positive whatever value, be it 2, 4, 8, any factor of 2, which is positive, we change it to -1. And similarly, we change it to +1 otherwise, from -2 to 1 or whatever. But our position still remains the same. So if we, for example, do a processing of AAR, then we change our position from 0 to 1, 1 to 3, since two A's are there, and our speed changes from 1 to 2, 2 to 4. And then we encounter a R, so our position still remains the same, but our speed changes to -1 from positive. Now, if we do another R, suppose EAR E was given, in that case, our next position will be 3 minus 1, that will be 2, and our speed becomes -2. So it starts going in the opposite direction, right? And we are given a target value which we need to find in such instruction, which is the shortest, such that we can get to target. So this is a hard problem, and I'm going to show you the dynamic programming solution, which is very unintuitive, but this can also be solved using BFS, using a graph problem. But I'm not going to show that here. Uh, let's see how we are going to solve it using DP. Let me take one example. If I take target as uh, 9, right? So if we have a function called solve, which takes target, let me use T instead, then this function should give me what? The minimum number of operations to reach target, right? What can be that? How can we reach 9? I'll say that we can reach 9 in two ways, and that is, uh, let's see that, or what can that be? We can use A as the first instruction because we are at 0 and our target value is always going to be positive as given in the question. So we are always going to use as the first instruction as A. So first instruction as A, which means we are moving from 0 to 1. Alright, second instruction as A again, and our speed also changes from 1 to 2. Okay. So second instruction will be 2 plus 1, 3, and speed becomes 4. One more instruction because we are still far away from 9. We change to 7, 4 plus 3, 7, 4 to 8, A. Now, if we do one more instruction, we are closer to A from one side, from its lower side, but from its higher side, if we do another A, we reach its higher side, which is not 9, it is 15. This will be 16. Alright, so what I am going to say is I can reach 9 from here. Let me call it uh, uh, LS, and I can reach 9 from here. Let me call it HS. So I'm going to say that this is nothing but minimum of LS target ls, sorry, and hs. Actually not, solve of ls and solve of hs. Not really, but this is what I'm starting with. This is not really the solution, but this is part of that solution. But how we are going to solve this ls and hs? Because we are not going to use a, or we are not going to use state r, right? We are have to, I mean, we are going to use r for this one because this is the only way we have to reverse the direction. We can't, uh, I mean, keep moving forward and away from the target. We have to move closer to the target. For that, we are going to use r here. And what about this one? We are going to use l here. I mean, not l here, again r here. Why r? Because if we go with a, it becomes, I mean, the same case that we have solved here, right? But that we don't want. What we want is we use R, we go certain uh, steps left. This can be I is not defined. In the question, we are going to use all the values of I that is possible. That is 0 to n minus 1. If this is n, then n minus 1, 0 to n minus 1, I value is going to iterate. And till whatever point it, I mean, takes us, we'll go to that point, and then we are going to again use a R to reverse the direction, and finally we are going to use is, sorry for my bad handwriting, is to finally reach target. So this is a little bit more complicated, but this one is a little simpler because after R we are going to straight away use is. Right. So this is the crux of the problem, but now comes the math part of it. Since we reached 7, right, from 0 to 1, 1 to 3, 3 to 7. So what are the number of steps? Since we are doing a dry run, we can just count it 1, 2, 3. Right? 3 steps it took us. And our target was 9. It took us 3 steps to reach 7. But what if the target was 7 itself? Right? In that case, we can straight away return 3. Right? We could have straight away returned 3. Now comes the question that how we are going to count this since we are not going to iterate and go to this point, we can just do that using a single operation, that is a bitwise operation, log 2 of n plus 1. This is nothing but gives us the number of bits required to represent a number. So for 7 we are going to have 3. 1, 2, 3. That is the number of rows. Similarly, for 15, we can have log the base to n plus 1. That is going to give us a number of operations to reach 15. Now that is the thing that we are going to use for all the scenarios. Like for the scenario this one, for the scenario this one, and for the scenario that we change the direction and start moving in reverse. Similarly, for this one as well, we are going to use this formula here as well. And again, when we change the direction, we are going to use the formula here as well. And finally, we are going to combine these and combine this and take the minimum of the two. It's a little bit uh, tricky to understand, but I hope that code is going to make things easier. So if I try to if I try to uh, write the recurrence relation, let me see, solve of t, right? The first thing that we are going to check is n. We are going to calculate. That is nothing but log 2n plus 1. Sorry, t plus 1. This is going to give us the overshooted value above t, right? This is going to give us that. If 2 to the power n minus 1, since the position and speed relation is nothing but 1, 2, 4. If this is position, then the position, if this is speed, then the position value is nothing but 0, just one less than the whatever speed value is. 1, 3, and so on. This will continue, this relation will continue, and that's why we are going to take 2 to the power n minus 1 if it's equal to target already, then we return straight away with n, right? And if it's not, then we are going to calculate from the overshooted value first. That will be something like 8 temporary or something is equal to, it's going to be the difference, right? For example, my target was 9 and 15 was my value that I reached, the overshooted value that I reached. So what is the difference right now? What is the difference? It's nothing but e to the power n minus 1, which took me to reach this point, minus target. That is this one. This is the difference or this distance that is currently existing. So it's nothing but n to reach 15 plus solve. Actually, before solve, we are also doing a reverse here, right? That is going to take one operation. So n plus 1 plus solve of 2 to the power n minus 1 minus target t. This is my first recurrence. Now my second recurrence will be for the undershooted value. That will be nothing but, let me remove this for now, 10 is equal to minimum of, so I'm combining this 10 or the point that is 7, right? So 7, for reaching 7, uh, if it took n moves to reach 7, then it took n minus 1 moves to reach, if it took n moves to reach 15, then it took n minus 1 moves to reach 7. So n minus 1 plus a reversal, because from 7 we are going to reverse, of course. So 9 plus 1. Now I go in the reverse direction, right? I go reverse direction from 7 by how many points? By some I points which is not defined, and which we are going to do a brute force for all the values of I before uh, n minus 1, right? So from 0 to n minus 1, we are going to use a brute force that will give us that this will be inside a loop. I will be from 0 to n minus 1, not including n minus 1, so less than n minus 1. All right, so this I is going to take I steps, and now where am I? I am going to use a solve. Sorry, before that, I'm also going to reverse again because from I am going in the reverse direction. So I'm going to reverse again, reverse back. This will be I plus 1 plus the final thing will be solve of what? I have traveled till 7, so I've come closer to 9. Then I went far from 9 by I steps. So currently I stand here. This is the distance that I want from 9. What can that be? So that is nothing but target t minus 2 to the power. This is nothing but n minus 1. So 2 to the power n minus 1 minus 1. This is subtracted from t, and we added the distance. We moved far away from I, right? So this is plus. I'm writing it here instead. It's a very messy piece here. Uh, so I'm adding I. So 2 to the power I minus 1. So t plus 2 to the power n. Actually, this is not plus. This is the plus that I'm. So t minus 2 to the power n minus 1 minus 1 plus 2 to the power I minus 1. Right? So this is what we are going to use. And we are going to minimize it to, use as a cache so that we are not taking the same, calculating the same value that we have found earlier. So finally, a vector, or let me just take the cache later of I, return solve target. Alright, should be int solve target. Here I'm going to calculate n first, like I did here. N will be log 2 of target plus 1 plus 1. Actually, floor value of this. This will be converted to integer and then implemented by 1. If 2 to the power n, which is nothing but in which I can write 2 to the power n like this, minus 1 if it's equal to target already, then I return n. Otherwise, I'm going to calculate, I'm going to calculate like t is equal to 1 plus, not 1 plus, let me see, this one, n plus 1 solve of 2 to the power n minus 1 minus n plus 1 plus solve of 2 to the power n minus 1 minus target. This is one value, and I'm going to run a loop now. I is equal to 0, then I less than n minus 1, I plus plus. So I've run this loop right now, and inside I'm going to check for the minimum value for t. And this time I'm going to check for solve. Or before solve, I'm going to count the current steps. So n minus 1 have already reached till 7, I mean as per the example. Then I have done a reversal. Then I have done I steps. Then I have done again a reversal. And then finally solve of target minus e to the power n minus 1, right, e to the power n minus 1 plus 2 to the power I minus 5. So this is the whole. Actually 2 to the power n minus 1 minus 1, right? Target minus 2 to the power n minus 1 minus 1. I'm not done a minus 1 and a minus 1 this side because it's going to subtract itself, right? If we see, this will be plus 1, this will be minus 1, so it's going to subtract each other. So that's why I don't need this. And I don't need this. Alright, then just do like this and return t. Now I'm going to do a cache. Cache will be nothing but dt of, I can take 10 to the power 5, so 10 to the power 4, or instead I can just take target plus 1 as well, that will also be fine, and minus 1 initially. I'm going to take this dp inside the parameter. This will be integer, this will be the width reference. Here I'm going to check if the dp value of target, if it's already not equal to minus 1, then I'm going to return dp of target equal to, yeah, return this. Alright, so this is it. Here instead of t, I'm going to take dp of target, or dp of n instead, yeah. Here as well, dp of n. Let's see if this works. We're going to pass dp. Here I need to pass dp. Here I need to pass dp. Let's see now if this works. It does. Since we are jumping from log to the base 2, so that is the wrong answer. If it's not equal to minus 1, but I guess it's equal to the target, then it's fine. This is also fine. This is fine. This is fine. N plus I plus 1. This is fine. Actually, I should use DP of target instead. Here, I should do this instead because this is what I'm solving for, right? In DP for target, I'm going to have this value, right? So this is DP being accepted. Here, the time complexity will be, since we are traversing to the into certain points instead of just traversing to all the positions, we are straight away jumping to 7 and straight away jumping to 15 instead of going from 1, 3, 15, and 7, 15, right? That's why it's going to be log n log n, right? For n jumps, since we are also having a loop, the jumps will be n log n, and the space complexity will also be n log n, I think. All right, this was a hard problem. Uh, if you didn't understand the solution, try to dry run like I did, and that's going to help in understanding better. Thanks.